Okay, figure 3.15, this is what we're looking at, shows the free fall of a heavy ball bearing released from rest at time t equal to 0 seconds. Letter A, how many meters does the ball fall in the first 2 seconds? Letter B, what is its velocity, speed, and acceleration at t equal to 2 seconds? Okay, so how do we answer letter A? Well, we use this position function s of t equal to 1/2 gt squared, where g is the acceleration due to gravity, and since this is in meters, that means the g would be 9.8 meters per second square, and take half of that. So what do we have? We've got s of t would be 1/2 9.8 times 9.8 t squared, so that's going to be 4.9 t squared. So s of 2 will answer letter A, and that'll just be 4.9 times 2 squared, which is 4.9 times 4. That's really 9.8 times 2, so it's going to be 19.6 meters. Letter B, what is the velocity, speed, and acceleration at t equal to 2? So first of all, when we want to find the velocity, that is v of t. That's just the derivative of s of t. So you're going to get 2 times 4.9 would be 9.8 t. Okay, so the velocity at 2 seconds would be s prime of 2. So that's 9.8 times 2 gives us 19.6. What is the unit of measure? Because it's with respect to time with its derivative, and remember velocity is a rate of change, instantaneous rate of change, so that's going to be meters per second. Okay, what about the speed? Well, the speed is just equal to the velocity, its absolute value. So that's absolute value of v of 2. So that's the absolute value of 19.6, which is equal to itself, 9.6 meters per second. And then acceleration would be the derivative of the velocity, which is the second derivative. That gives us, what's the derivative of 9.8 t with respect to t? It's just 9.8, which is indeed your acceleration due to gravity. So it's fixed. So that's going to be meters per second squared, because you took the derivative of the position function 2 times or twice. Next. Okay, example 4. Right, here in example 4, we have a dynamite blast blows a heavy rock straight shut, and it goes up, like suppose it blasts here, kapoosh, and then goes up, and then it reaches a height there, and then comes back down. Okay, so it has a launch velocity of 160 feet per second, about 109 meters per hour. And then it reaches a height. So this is the function of the height, or the position function, which is 160 times t minus 16t squared. Notice that that is due to the free fall. That means due to gravity when it comes back. Okay, and then 160t, that's the initial velocity. So when you multiply by time, you get the distance. So this is s equal to feet after t seconds. Letter A, how high does the rock go? Letter B, what are the velocity and speed of the rock when it is 250 feet above the ground on the way up and the way down? What is the acceleration at any time? And when does the rock hit the ground again? So let's look at the picture. You've got the rock being blasted up, then it goes up, and due to gravity, it's going to have to come down back to the ground. This is just the graph of the position function. This is not the path of the rock, okay? Because this is how it went up, just came down. This is just the graph of this function s equal to 160t minus t squared. Okay, so how high does the rock go? Well, if you notice from this picture, it reaches up at that level. That's what our maximum height is. And that's when it changes direction because you know it went up. Now, when will it change direction? That means it changes direction when the velocity is equal to zero. So let's go ahead, therefore, and take the derivative of s of t. Okay, so to answer, we need to take first we set the derivative to 0, and then we solve for t. Okay, so here's your position function. What's the derivative? 160 minus 32t, right? Then set it equal to 0, and we solve for t. What do we get? Well, you add negative 32t, add 32t both sides of this equation, and divide everything by 32, you get t equal to 5. Where do I substitute t equal to 5? Well, it says how high, so that means it's a measure of distance or height. So where do you substitute t equal to 5? You substitute it back into s of t. So now we get s of 5 equal to 160 times 5 minus 16 times t squared, which is 25. Do all the math there, you get 400 feet. What does this tell us? That means that after t equaled 5 seconds, it reached a maximum height of 400 before it comes back to the ground. All right? Okay, letter B. What are the velocity and speed of the rock when it is 256 feet above the ground, on the way up and on the way down? Look at this picture again. Somehow between 0 and 5, or 5 seconds, or a distance of 0 to 400 maximum, there's got to be a 256 height reached somewhere between 0 and 5 seconds. So how do we do that? Well, in order to do that, to find when it reached that height, because why do we need to find when it reached that height? So that we can find the velocity right at that second, that t equal to whatever many seconds. Okay, so the thing we do is we solve s of t, which is 160t minus 16t squared equal to 256. So if you think about this, put everything and set equal to 0, you're going to get 0 is equal to 16t squared, right? Minus 160t plus 256. Okay, now everything is divisible by 16. So let's divide everything by 16. And what do we have? 0 is equal to t squared minus 10t, okay, plus 16, 256 divided by 16 is 16. So what are the factors of 16 that make up 10? That will tell us that if we factor, we get t minus 8 and t minus 2 equal to 0. Therefore, t is equal to 8 and 2 seconds. So obviously at t equal to 2, that's when it reached 256, then went back up and reached 400 feet, and then came back down at t equal to 8 seconds. There it's back again to that 256 distance from the ground, and then back to the ground. Okay, so have we finished the question? No. So far we just found the time when it is 256 above the ground. So the next thing we got to do is to find the velocity. Okay, so how do we do that? Well, let me see. Just remember it's t equal to 2 and t equal to 8. So at t equal to 2, we got to find the velocity. So v of t is 160, just differentiate s. Okay, so right here, differentiate s. So 160 with respect to t minus 32t. Okay, and then what's next? Well, you substitute v of 2. So we get 160 minus 32 times 2. That's 160 minus 64. And what do we have? That's 96, right? Okay, so 96. Now, what is the unit of measure? Because it says velocity, it's a rate of change. First derivative of s of t, so that's going to be feet per second. Okay, so that is the velocity at the instant t equal to 2. Now, what about the speed? Well, speed is the same. So speed is just the absolute value of 96, which is the same as 96. Okay. Now, what happens at t equal to 8? Okay, so at t equal to 8, v of 8 would be 160 minus 32 times 8. So what is that? Okay, when you multiply everything, that's going to be 160 minus 256. So it's really equal to negative 96 meters per second. Okay, now, or feet per second. Feet per second, sorry. Feet. Let me erase that. It's going to be feet per second. What is the speed? You just take the absolute value of negative 96. So you get 96 feet per second. Same thing here, that's also feet per second. Okay, so that answers the question. On the way up, it's 96 feet per second. And of course, on the way down, you have an opposite direction. The velocity is negative, so it's negative 96 feet per second. And then same speed, okay, because you just take the absolute value of the velocity. Right. When does the rock hit the ground? Well, what do you think? When does the rock hit the ground? That means when s of t is equal to 0. So we got to find the time when s of t is equal to 0. So you've got s of t, 160t minus 16t squared. Okay, set that equal to 0. We see that 16t is a common factor. So we get 10 minus t, right? Set that equal to 0. So you have 16t is 0, which means t is equal to 0, of course. And then the other one is 10 minus t is 0. Obviously, t is equal to 10. And we can't choose t equal to 0 because that's really the initial time, but we take t equal to 10 as the seconds when it hits the ground. Okay, so t equal to 10 seconds. All right, so that answers this question up to letter D.